Q8394. A hot start in a turbine engine is caused by A. Failed ignition. B. The engine's failure to accelerate. C. Too much fuel in the combustion chamber. The correct answer is C. Too much fuel in the combustion chamber. A hot start in a turbine engine refers to a situation where the engine's combustion chamber experiences excessive heat during the starting process. This can be caused by an excess amount of fuel in the combustion chamber. During the engine start, the fuel is introduced into the combustion chamber and ignited. The combustion process generates heat, which in turn creates the necessary gases and energy to drive the engine. However, if too much fuel is introduced or if the fuel-air mixture is not properly balanced, an excessive amount of fuel can accumulate in the combustion chamber. When there is an excessive amount of fuel in the combustion chamber, it can lead to a higher than normal temperature. This can result in increased heat, higher pressure, and potentially damaging conditions within the engine. The excess fuel can cause an unstable or uncontrolled combustion process, leading to high temperatures and potentially damaging hot spots. A hot start can have various adverse effects on the engine, including increased wear and tear on components, potential damage to the combustion chamber, and reduced engine performance. It is essential to ensure proper fuel-air mixture and adherence to starting procedures to avoid hot starts and maintain safe engine operation. Therefore, option C, too much fuel in the combustion chamber, is the correct cause of a hot start in a turbine engine. 8394-1. What could cause a turbine engine hot start? A. Lack of airflow due to insufficient turbine RPM. B. Inlet and compressor airflow imbalance. C. Insufficient fuel in the combustion chamber. The correct answer is C. When the exhaust gas temperature rises over the aircraft's safe limit, a hot start happens. This problem is also known as a hung start and is brought on by either too much fuel entering the combustion chamber or not enough turbine RPM. 9060. The most important restriction to the operation of turbojet or turboprop engines is A. Limiting compressor speed. B. Limiting exhaust gas temperature. C. Limiting torque. The correct answer is B. Limiting exhaust gas temperature. The most important restriction to the operation of turbojet or turboprop engines is typically the limiting of exhaust gas temperature. This limitation is crucial to ensure the engine operates within safe parameters and to prevent damage to the engine components. Exhaust gas temperature, EGT, is a critical parameter that directly correlates with the combustion process and the overall health of the engine. If the EGT exceeds the manufacturer's specified limits, it can lead to various issues such as turbine blade damage, overheating of engine components, and potential engine failure. By limiting the exhaust gas temperature, the engine's operating conditions can be controlled and kept within safe boundaries. This is typically achieved through various means, including controlling the fuel flow, adjusting the turbine inlet temperature, and optimizing the engine's airflow. While compressor speed, A, and torque, C, are important parameters in the operation of turbojet or turboprop engines, they are not typically the primary restrictions. Compressor speed is usually regulated to maintain the necessary airflow and pressure ratios, while torque is primarily relevant to turboprop engines and relates to the power output of the propeller. However, exhaust gas temperature remains the most significant restriction to ensure the safe operation of these engines. 9064. What characterizes a transient compressor stall? A. Loud, steady roar accompanied by heavy shuddering. B. Sudden loss of thrust accompanied by a loud whine. C. Intermittent bang, as backfires and flow reversals take place. The correct answer is C. An intermittent boom, when backfire and flow reversal occur, is the sign of a transitory, intermittent compressor stall. If the stall progresses and becomes stable, a loud roar and a powerful vibration result from the ongoing flow reversal. A persistent halt poses an imminent risk of harm. Reduce the throttle setting, decrease the plane's angle of attack, and increase velocity to fast complete the recovery. 9768. What prevents turbine engines from developing compressor stalls? A. De-ice valves fuel heat. B. TKS system. C. Compressor bleed valves. The correct answer is C. Compressor bleed valves play a crucial role in preventing turbine engines from developing compressor stalls. A compressor stall occurs when the airflow through the compressor becomes disrupted, leading to a momentary disruption in the smooth flow of air and potentially causing engine performance issues or damage. Compressor bleed valves are designed to release a controlled amount of air from the compressor's high-pressure stages. By bleeding off a portion of the compressed air, these valves help to maintain the proper airflow and pressure distribution within the compressor. This prevents the buildup of excessive pressure or disruptions in the airflow that can lead to compressor stalls. When the compressor bleed valves open, they redirect some of the high-pressure air back into the engine's inlet or other areas of lower pressure. This action helps to alleviate the effects of disturbances, such as sudden changes in operating conditions or disruptions in the airflow, which could potentially cause compressor stalls. Options A and B, de-ice valves/fuel heat and TKS system, are not directly related to preventing compressor stalls. De-ice valves and fuel heat are primarily used to prevent or remove ice accumulation on the engine or fuel system, respectively, which is a different concern. The TKS, anti-ice, system is typically associated with protecting the aircraft's wings and other surfaces from ice buildup. While these systems indirectly contribute to safe engine operation, it is the compressor bleed valves that specifically address the prevention of compressor stalls by managing the airflow and pressure distribution within the compressor.